Session this afternoon. So good afternoon and welcome all. My name is Eddie Ritson. I am the Director of Digital Transformation and Innovation, working within the Digital Health and Care Northern Ireland team. So you're all very welcome to this digital dispatch where we will be learning about the utilisation of artificial intelligence in radiology under an initiative referred to as Boneview. This is the 48th in the series of the HCNI digital dispatches. The session today is being recorded, and whenever it has been subtitled, it will be available on our YouTube channel and also on the DHCNI website, where you can view also previous episodes, and we'll perhaps, Jennifer, put a link to the DHCNI website into the chat. Today's session is scheduled to last for 1 hour, and we will be finishing at 2 o'clock or before, if appropriate. I would ask you, if you haven't already done so, if you would mute your microphone, and I would encourage you to use the chat room for any questions that may come up, and we'll come back to that after we've heard the guts of the presentation. Just a little bit about artificial intelligence. So we all hear so much about it in society these days, and the impact that it's going to have on so many walks of life. And of course, it may be that there's a certain amount of hype around this new technology. From the Digital Health and Care Northern Ireland perspective, we have formed a steering group to help to guide how, as a system, we go about utilising AI to improve quality and efficiency. We have a work programme ahead of us, and it includes creating the means by which there can be wide engagement across the service on artificial intelligence. We are developing a framework to help guide the system in the responsible and ethical application of artificial intelligence. And we are in the process of establishing a repository of examples of AI in delivering care and best practice. So we've got some work in hand around those areas. So I'd like now to introduce Joanne Allison. Joanne is the Programme Manager for the Northern Ireland Picture and Archiving Communication System, often referred to as NIPACS, or shortened to NIPACS. And Joanne's going to be telling us about the work which has been going on in radiology under an initiative, I say, referred to as Boneview, which is acquiring quite a lot of attention in the delivery of care and indeed in local media. So Joanne, you're very welcome, and thank you for taking the time to be with us today. I think you're going to be using your own set of slides, Joanne, so we'll let you just kick off from there. A number of you will have cameras off, so that's fine. You might be getting a bite of lunch perhaps during this digital dispatches, but please do feel free to switch your camera back on whenever it suits you. It's always good to know we're talking to real people and not just tiles on the screen. So Joanne, it's over to you. Thank you.
Thank you very much, Eddie. I'm NIPACS Plus Programme Manager. So just to start off, can anybody see my screen, by the way? Can everybody see it okay? Good. As Eddie has said there, that NIPACS stands for the Northern Ireland Picture Archiving and Communication System, and it was first implemented in 2009 and saw the digitisation of radiology imaging for all hospitals in Northern Ireland, with the exception of the Royal Victoria and Belfast City hospitals. Then in 2020, digital pathology was introduced. Again, that was moving from analogue to digital and provided the ability to store and manipulate whole slide imaging within NIPACS. So the cohort of imaging that was in NIPACS was plain film, including DEXA, CT, nuclear medicine, fluoroscopy, ultrasound, MRI, and then, of course, digital pathology in 2020. And then comes NIPACS Plus. So for those that don't know what the plus means, it means that it built on the 14 years of work that the original NIPACS initiative and they plus incorporated the Royal Victoria and Belfast City Hospitals, and then many other additional imaging specialties. And NIPACS Plus was the first UK enterprise imaging service which combined imaging from a diverse range of specialties and allowed for a single point of access for imaging to enhance patient care, improve patient safety, and support timely diagnosis for patients. So the imaging cohort then was the NIPACS in the top left-hand corner there. And then we included, as I say, Royal Victoria and Belfast City, and then cardiology, endoscopy, ophthalmology, obstetrics, dental, and medical photography. So with the addition of those image types and the RVH and BCH, the enterprise solution provides an excellent platform for regional AI implementation. We have the infrastructure in place via Sector's Amplifier Marketplace to implement AI directly within our solution, and AI results and outputs can be viewed regionally. But AI in healthcare. There are many areas for use of AI within healthcare, and it continues to be developed and deployed globally. Machine learning, natural language processing, and computer vision are used for disease diagnosis, drug development, and administrative tasks. Generative AI and agentic AI for creating content, robotics for surgery, digital twinning to simulate disease progression and optimize care plans, and even readmission forecasting using predictive models. But what I'm going to talk about is AI in medical imaging. So imaging AI algorithms excel at recognizing patterns and anomalies in imaging, ultimately aiding diagnosis, treatment planning, and research. AI can enhance the accuracy and efficiency of disease diagnosis with speed and precision, and this early detection is crucial as it can lead to timely interventions and improved treatment outcomes. It's important to note, and I'll say this quite a lot through this presentation, that AI's role is not about replacing people, but making their work more efficient. Medical imaging data is one of the richest sources of information about patients and often one of the most complex to interpret. AI has already proven that it may be a valuable partner for clinicians wanting to accelerate their productivity. AI should not be implemented, though, without rigorous structures and processes, and oversight is essential to mitigate risks and ensure its safe and effective implementation. So the Region Medical Imaging Board established an AI imaging subgroup consisting of both clinical and non-clinical representatives to oversee and govern the development of an AI strategy for medical imaging in Northern Ireland. Its aim included establishing collective leadership and designing the operational processes for implementing AI in imaging. The subgroup provides a framework for a regionally coordinated approach, ensuring maximum benefit and wants for Northern Ireland. AI should enhance rather than replace the expertise of professionals, and it has the potential to revolutionise HSC NI by boosting productivity and improving patient care. But before you investigate whether to use AI or not, it's important to define the project scope. What is the problem you're wanting to solve, and can AI solve it? What is out there to exist? You need to explore solutions, ensure regulatory compliance, understand your evidence base, understand the accuracy, clinical impact, workflow integration, and finally acquisition and deployment. Within NIPACS Plus, we can select AI vendors from Sector's Amplifier Marketplace. The marketplace offers a selection of AI applications for the purpose of achieving value in clinical practice. It acts like a storefront, like an app store, and all applications are verified and validated for clinical use, either CE or FDA approved. So the AI subgroup developed a regional process for proposing and implementing AI solutions. Even though we have the infrastructure in place, it's not, and nor should it be, a quick process to implement AI. There are several elements that we need to complete. To ensure transparency and accountability in AI decision-making, it was imperative to satisfy information governance, cyber, networks and security teams within BSO and the trusts of the architecture and data flows to and from the NIPACS Plus environment. This was to reassure that the processes regarding patient data, anonymization, etc. were all being met. Once we had the approval to proceed, subgroup members agreed that its first deployment and proof of concept of imaging in AI would be for detecting traumatic lesions on plain film X-rays. We selected Gleamer Boneview from the Amplifier Marketplace. As this slide demonstrates, Boneview detects fractures, effusions, and dislocations on plain film imaging on extremities, pelvis, thoracolumbar spine, and the rib cage for adult and pediatric patients greater than the age of 2. So once we had all the preparation work completed, we moved to the next stage of local performance validation. Although Boneview has a large volume of deployments within the rest of the UK and statistics on benefits and outcomes were positive, it was really important ethically that we carried out our own retrospective evaluation. We transferred just over 1,000 cases of historic imaging into NIPACS Plus test environment. These images were processed, and then the AI output that was returned was evaluated alongside the initial clinical evaluation within ED and the official radiology report. And this was performed by Dr. Gibson, consultant radiologist, and Dr. Erskine, emergency medicine consultant in the Northern Trust. So the results were reviewed and the decision was made to process or to proceed to the pilot phase. Pilot implementation is performed in 2 different stages. The first is the workflow validation stage, which is referred to as shadow mode. And this allows key users access to the results for validation of the end-to-end workflow, ensuring the examination codes, referral sources, etc. have all been orchestrated correctly and the outputs are what is expected. It also allows the measurement of the turnaround times, which turned out to be less than 1.5 minutes, and provides the trust time to complete any necessary training for users. Shadow mode can run for as long as necessary to ensure that all parties are content on the workflow. So once shadow mode has been completed, the next stage is to go live with a pilot within clinical practice. Then ensure adoption with regular contact with the Trust PACS teams and the clinicians. And I can say that Boneview has now been implemented in all ED and minor injury units across the region. So measuring success is a multifaceted approach, and it includes the categories mentioned here. I think it's important to note that diagnostic accuracy is at the top and should be paramount when you're doing evaluations. Sensitivity is the ability to correctly identify patients with the disease. And the specificity is the ability to correctly identify patients without a disease. And the overall percentage of accuracy is the overall percentage of correct diagnosis, and that's calculated by considering both true positives and true negatives. And if the percentage levels in these areas are not high, then the pilot has not been a success. So this is a really important slide, and this is the results that Dr. Gibson and Dr. Jenkins, who evaluated the retrospective results within test environment, also completed the evaluation on the pilot phase. So the pre and post evaluations showed that ED initial clinical evaluation sensitivity increased to 94.3%, and the radiology sensitivity increased to 94%. And that was a 5.3% increase for radiology and a 14.5% increase for ED. And the overall missed fracture rate decreased by 5.6%, reducing it to 1.1 from 6.7. Really important there. So what does it actually look like in practice? Well, the Boneview results are embedded within NIPACS Plus as a secondary capture. And that secondary capture is a second set of images showing the AI findings. And those results are tagged as either positive, doubt, or negative. Images are acquired in the normal manner, and then when they arrive in NIPACS, they are exported pseudo-anonymized to Boneview for processing. The AI output is returned to NIPACS Plus within a short period of time, as I said, less than 1.5 minutes, and the secondary capture stack is available for ED staff to scroll through. And these outputs act like an instant peer review. And as I've said before, it's to assist the clinical evaluation, and that clinical decision remains paramount. So this is a typical view within the matrix window of NIPACS Plus. These images have all been anonymized, but I've also blocked out other areas just to make sure that there's definitely no patient identifiable information here. So the images are acquired as normal, and that's these images in the red bounding box. Then they are sent to AI for processing, and the output is returned as a secondary capture. What does that secondary capture look like? So this will be the top image on it, and we can see that you've received 2 images and analysed 2 images, or Boneview's received 2 images, analysed 2 images. It has said, yes, there is a fracture there, but there's no dislocation or effusion. The image behind that, you can see that Boneview has returned it with a yellow bounding box saying fracture on the first image and again on the second image. And you can see it clear on the second image here, but that is definitely positive for a fracture of the distal radius, which is your wrist. Okay, the second set of images that we're going to look at is this wrist X-ray here. Now you can see this, there's been previous surgery on this hand or in this arm. Those images were required. This is what was returned from Boneview. 2 images received, 2 images analysed, and this time there is a doubt of a fracture, no dislocation or effusion. There is no area interest on the first image. On the second image, Boneview has placed a dotted bounding box around where they believe, or they think there is a fracture. There's certainly an anomaly there that needs further investigation. And that's it. Just I zoomed in a little bit for you to see. But this is really important, and this is where the clinical evaluation is always paramount, because it turns out that there is no bony injury identified on this image. You can see where it probably thought there was, but there's nothing there. And this last set of images, this is gone out to Boneview, returned as negative. And again, we're just clarifying it received 2 images, analysed 2 images, and there is no fracture, dislocation, or effusion. So we mentioned some of the benefits on the slide from the pre and post evaluations. But here is just some more. So seamless integration. The Amplifier marketplace is integrated into NIPACS Plus infrastructure, and there are many algorithms on that support the most prevalent use cases for AI. All applications have been validated and verified for clinical use and integrate seamlessly into NIPACS Plus clinical workflows. Enhanced diagnostic accuracy. AI, as I've said, can detect abnormalities with a high percentage of sensitivity. It can prioritise cases for urgent radiology reporting, and all images are still final read by the radiology department in the normal manner. But this is just acting like a peer review or a second pair of eyes. Feedback from the trusts is that there is a definite continued improvement in the accuracy of initial clinical evaluation, and that's the first read of your bone X-ray while in ED, waiting for the formal radiology report. ED clinicians report that it has boosted resident doctors' confidence in interpreting X-rays. It's reduced the need for second opinions from senior staff, and as the initial statistics showed, it has led to fewer missed fractures. Senior staff have also reported time savings as they spend less time contacting patients for follow-up on missed fractures. Reduced turnaround times. Algorithms provide faster image analysis, assisting in the backlog of reporting that departments are struggling with. AI-assisted workflows can significantly reduce image interpretation time and can also alleviate burnout. Some emergency departments can often wait up to 72 hours or longer for the formal radiology report to return. With Boneview, the timeliness of diagnostic accuracy is reduced to immediate. For patients, it means faster, more accurate diagnosis, resulting in better treatment. And finally, workflow optimization. As mentioned previously, AI is integrated into NIPACS Plus workflows so that already embedded workflows remain the same. Positive or doubt outputs can be prioritised in reporting work lists, putting them to the top for urgent reporting. But as with any project, there comes challenges. So data security and privacy, including information governance and ethics in that, ensuring that transparency and fairness and accountability in AI decision making is important, and that took several months to go through all those processes to make sure everybody was completely satisfied. Clinical validation. Any algorithm needs to be validated, and this requires significant clinician time. It took several weeks for both the historical evaluation and then the pilot evaluation, and that was performed outside of their clinical duties. So you do need to get clinician buy-in and get their time. Organizational culture. People inherently don't like change, and particularly within our health service in this past year and a bit, there's been a lot of change within Compass and different programs, Compass, NIPACS Plus, NIPIMS. There's lots of change. But it's human to assume that AI is something that's going to replace staff or their role completely. I've mentioned this before, but it is not the case. AI is an augmentation tool and should be used to assist, not to replace. Staff also raised concerns about de-skilling. Is AI going to, they're not going to have to use their clinical opinions. AI is going to say it all. Again, that's not the case. And that's where we needed to reinforce through training that their clinical evaluation is always paramount. And finally, clinical trust. There is a necessity to build confidence in AI outputs through rigorous validation, peer review, and then continuous evaluation once it's been rolled out. Defining clear clinical accountability and ensuring that the clinicians know that they are the final decision makers with regards to treatment. Everyone should be reassured of the rigorous data security, privacy, and governance processes that were followed, and that we are not implementing AI for the sake of implementing AI. Seamless integration that doesn't disrupt existing workflows also aids to clinical adoption. There is the need to build confidence and trust by explanation and transparency, providing training and equipping staff with information to ensure the continued optimal patient care and safety. So despite the challenges encountered, the benefits of AI for patients across Northern Ireland far outweigh the justified efforts to reach this point. I believe AI is vital to the future of our health service, and how we apply it to enhance diagnostic and improve patient care is what matters most. So the subgroup are investigating a comprehensive chest X-ray clinical support triage tool that will automatically prioritise clinical, critical and urgent findings, ensuring time-sensitive chest X-ray cases are triaged and reported on more effectively. Now, we have chosen a vendor for this. We are in the process of getting that vendor into the algorithm into our test environment to go through the same process that we went through with Boneview. There will be lots of cases, 1,000+ cases run through the algorithm so that we can do our own clinical evaluation. And that is hopefully going to begin before Christmas. So early next year, we will hopefully be in a position to roll out this chest X-ray algorithm. So looking at algorithms that will assist pathologists in reporting whole slide imaging within NIPACS Plus, and that is for breast and prostate cases. And finally, just to say that AI is not a silver bullet. It's not going to fix everything, but it really is a powerful tool when it's implemented thoughtfully. Our experience with NIPACS Plus shows that success depends on clinical engagement with your clinicians. You need that clinical trust, robust governance, and a shared vision for better patient care. And that is me. Eddie, I will stop sharing.
Yeah, that's great, Alison. That's great. Thank you very much, Joanne, for that. It's very it's great to see a practical application of artificial intelligence, including in your presentation about how it actually presents, from an operational point of view with the pictures and the yellow boxing of where the fracture is, etc. It sort of, to my mind, it takes away some of the mystique. It makes it look quite sort of real and practical. So we'll turn to some questions in a minute or two, and I'll review the chat room. But just to get us going, you've mentioned there about what patients think about the use of AI. Do you want to perhaps expand upon that a little bit? And because some people might be concerned about how their data is being used and how it's being consumed and so on. Are there any issues around that? Are there any opportunities to allow people to opt out of this application? How does all that work?
Okay, we had some very in-depth conversations with information governance around this. The information flows. There are no concerns from an information governance point of view or any sort of technical point of view on patients' data. It is all treated appropriately. However, the information governance decided that because there was posters in the waiting rooms advising patients that their X-ray may be read by AI, that was enough to inform them. There was everything is pseudo-anonymized. There's no patient data leaves our environment. So it was thought that they didn't need to have an opt-out at that point. However, as you say, we're getting more traction in the media and different things like that for Boneview. and then potentially the chest X-ray one that's coming next, there is the technical ability to be able to opt out. The patients will have to advise the radiographer at the time of the acquisition of the image that they don't want it to go, and then it's a matter of a tick box. So the patients can and will have the ability to opt out.
Right, that's very interesting. Thank you. So just looking at the chat room, I see there's a question here, Gary, from yourself. Do you want to speak to that, Gary? Or do you want me to go ahead with it?
No, dead on, John. It's just basically out of curiosity. Are the decisions that we make, our clinicians make within Boneview, are they fed back for training and improvement of the AI itself?
They are, Gary. Whenever the X-rays are read by the radiologist in the radiology department, there is again a button that you can click. It's a false negative button or a false positive, and those are all captured and gathered, and we feed those back to a Gleamer Boneview, and that is used, as you say, to develop and to improve on their algorithms. Yes, none of our patient data is given to Boneview. Everything, if they look at the images, but everything, all the metadata is stripped out. But yes, it is used to improve performance and their algorithms for the future.
Thanks, John. And if I could ask another question.
You've got the floor, Gary.
Joanne probably knows where this is coming from. Again, Joanne is just keeping up to date on the progress around the breast, especially for screening. Be really important. I know the National Screening Committee are trialing AI for breast screening, and I know that some of the amplifier marketplace products or sector themselves are part of that, but that can't be trialed in Northern Ireland at the minute. It'd just be helpful to know how we might progress that down the line. And just very tangentially and linked to that is the bit on lungs. So next year, a plan is being developed by PHA and SPPG to deliver a new lung cancer screening programme for Northern Ireland. It'll be another adult screening programme, and I'd be just interested to keep in touch on that to ensure that we're using all the best technologies and plan for that.
Absolutely, Gary. The vendor that we're looking at for the chest X-rays can detect over 100 abnormalities in a chest X-ray, and again, it's returned very quickly. So if you have a lung cancer pathway, you're no longer waiting days, or longer for the report. You can get your AI finding.
No, thanks very much, and great work.
But yes, we'll keep in touch.
Yep, thanks.
That's great. So I don't think it's a deliberate objective of these digital dispatches to enable dots to be joined around the system, but if it can, then that's great. Thanks, Gary, for raising that. I see there's a question in chat from Sue Hun regarding how you go about prioritizing areas for future development. Joanne?
Well, again, it's the AI subgroup, and it goes back to what are the problem areas and where do you see most benefit for the use of AI. And the chest X-ray, the Boneview one was primarily a proof of concept. Does the technology work and are all the integrations work? Although that is going to be important for ED staff. The chest X-ray one is really looking at what's on the market and what we can best implement. So that was the decision there. And then there are some backlogs with the digital pathology, and particularly the prostate scanning, getting those results back. So it's basically looking so is where it can provide most benefit, I suppose. But that's all decided through the AI subgroup, imaging subgroup.
Yeah, I suppose many of us have experience of trying to pursue initiatives across the 5 trusts, and it can be quite challenging in that context. And I wonder if perhaps just having that sort of clinical structure of the regional medical imaging board and as you say, the subgroup beneath that is a sound way of developing that buy-in which has been needed to ensure the successful rollout across 5 trusts. Like that's a challenge in of itself. Very good. And I see there's a question here from Lisa Canavan. Lisa, do you want to come in?
Yeah, it was just the Christie NHS Foundation Trust is working on a similar idea of using AI for chest X-rays, and I was wondering if you guys are working with them or have connected with them.
We haven't actually connected with them, Lisa, but we have connected with Grampian NHS Trust in Scotland, and we've also reached out to Greater Manchester using they've done the same thing with chest X-rays. So, but I will certainly take a note of that because every lesson learned is helpful. So, if they're doing it, I want to know what they're doing. Yeah.
I can pass you on the details. It was an actual radiographer who did a webinar on the work that he was doing. So I can pass you on his details if you want to reach out to him.
That would be great, Lisa. Thank you very much.
No problem.
Please do.
So Joanne, just another question from myself. So I was in another meeting yesterday when the subject of Boneview came up, and I did pick up that there was a passing comment made that it wasn't overly negative, you know, saying Boneview is very good, but it's quite costly. And I wondered if you might want to say something just about the financing of it and how the sort of the cost benefits stack up.
Okay, well, within NIPACS Plus, we have a small budget for AI and AI and innovation. But what we've done is we will provide these algorithms for the first year to 18 months, depending on the cost, to the trusts regionally, and then we will pass the cost on to the trust if they want to continue with it. But I don't think Boneview is costly at all. To run one of those X-rays or your a set of X-rays or an examination, to run it through the algorithm is just over £1, literally just over £1 to do it. The litigation costs for missed fractures in the trusts can be colossal on occasions, you know. So if you miss even a couple of missed fractures, and you say that the rate for the trust and the evaluation, you know, went from 6.2 to 1.1. If you miss, you cost the litigation cost of those missed fractures. You know, it doesn't cost very much at all for each trust to keep this going. You know, you're talking about 250 to 300,000 X-rays done regionally for that algorithm. So to me, it's not a lot of money.
Okay.
To run it through.
Thank you. So it's on a revenue-based model from Sectra for the Boneview application of approximately £1 per X-ray. Very good. And I see, so you popped another question into the chat. Do you want to come in, Sue?
Yeah. Hi, Joanne. Good to see you again.
Yes.
I just have another question, I suppose, because this is of interest to me. It's regarding the development of the AI skills, you know, for the people in the related to the project. Was it with the help of Sectra? How have you identified the skills required, and how have you gone about meeting those needs? And I'm referring kind of at all level, from a basic user to kind of people who have it on the imaging board who are having to make decisions about which type of AI to use and things like that. It's just again to get some benefit of your experience and insight. Thank you.
Okay, well, the training for the algorithms themselves for the end user for Boneview it's quite self-explanatory. However, we do have training manuals, and there's online training that we send out to all the clinicians. We make sure everybody has got their, within radiology, they've got their standard operating procedures. They know exactly what to be doing there. And then for the clinicians to review it at the other side, there's training documentation. There's online training provided through Sectra on their amplifier. And again, it'll depend on which algorithm is used, how much end user training is required. The chest X-ray one we're looking at, the interpretation of those is going to be a little more complex than the Boneview one, for example. So the training will differ slightly. But the skills are all, the training and the skills are all there and provided through Sectra. And your question about the subgroup, could you just repeat that for me?
Yes,
So
it's more also how do you support the imaging group, for example, the AI imaging group, in making decisions about, you know, which AI, what type of AI, what the risks are, what the governance arrangements, what are the pros and cons. How do you go about then, from a leadership perspective, supporting them in terms of the general AI awareness and what specific ones that they need to take into consideration?
The beauty of the sector amplifier marketplace is that all the algorithms are hosted within that, all the governance is the same, the data flows are the same. They've already been validated, verified for clinical use, FDA approved, CAA approved. We haven't actually, because we're not gone out to market yet into the procurement area to look for something, I suppose, that's not on the amplifier marketplace. That in-depth knowledge isn't required at the moment. You know, everything is there available. They can ask all the questions they have, and we have a sector amplifier team that can come over and discuss any of the algorithms with the subgroup to see which would provide the best clinical benefit depending on what they're looking to solve. You know, so without going through that procurement route, that we have the ability to do everything within the amplifier marketplace where it's all somewhat contained. Does that answer your question?
Supported by the vendor themselves,
yeah,
and obviously validated, because it's a validated product, you have less
exactly
concerns. But then
yeah.
again, you know, you've also, I think, consulted information governance, and presumably they have had some insights into what the product haven't are required, can or doesn't do. So the information governance people can also help you work through these different decisions. Okay,
absolutely.
So it's just useful to know for any other future AI deployments, you know, what level of AI skills we need to consider.
Yeah, our process to get everything validated to allow us to proceed through information governance, cybersecurity, DPIAs, GDPR, all those different things, all that took us nearly 11 months, you know, to be able to get to the point where we were able to proceed and actually get an algorithm into our test environment. You know, so because the knowledge, you're right, the knowledge is there, but it's getting into the in-depth and the nitty-gritties of everything that takes the time.
Yeah. Okay. Thank you.
Sue hasn't disclosed it there, but Sue's working to support the work of the AI steering group. So she's looking for tips, Joanne, about how that work might be rolled forward. So
I'm available anytime. So
when you've mentioned those hurdles you've had to go over regarding the IG and so on, I assume you've had to do that 5 times.
5 times.
Yeah, hence the 11 months. So very good. Thanks, Sue, for that. So just turning to the group in general, are there any other questions? I don't see any hands up just at the minute. Any more for any more? No, I think you're getting off light.
Getting off lightly, Joanne. That's great.
So it just turns me then just again to thank you all for coming along to this episode, and in particular to Joanne. If you don't mind me saying so, Joanne expressed to me before we started today that she's feeling slightly under the weather. So well done, Joanne. You've seen that through it really well. Congratulations. We DHC and I operate these episodes of Digital Dispatches on a monthly basis. However, there will be no Digital Dispatches in January, and the next episode is scheduled for Friday, the 6th of February, 2026. So that concludes our session today. And again, I'll close it there, and just to say thank you very much and enjoy the rest of the day. And if you're off the weekend, have a good weekend off. Thank you. Goodbye.
Thank you very much.
Thank you, Joanne. Thank you.